There's no such thing as an insignificant amount of ice. Frost, ice, or snow on the leading edge and upper surfaces of a wing with only the thickness of medium sandpaper can reduce lift by as much as 30% and increase drag by 40%. This will severely impact the controllability of the aircraft during two of the most critical phases of flight, takeoff and initial climb. In addition, the added weight of the contamination can be enough to put the aircraft over its maximum gross weight, which will further reduce the aircraft's ability to climb. The Clean Aircraft concept was developed by Transport Canada as a tool to increase and promote safety at all levels of aviation. The cars prohibit anyone from attempting to take off in an aircraft that has any contamination on its critical surfaces. And it's not enough to assume the aircraft is clean. The pilot in command must confirm it is, and then recheck if there's any doubt as to the state of the critical surfaces. A critical surface is considered to be the wings, control surfaces, rotors, propellers, horizontal stabilizers, vertical stabilizers, or any other stabilizing surface on an aircraft. And in the case of an aircraft that has rear-mounted engines, the top of the fuselage. Storing your aircraft in a hangar is one of the best ways to prevent contamination from collecting. Remember to complete your walk-around and have the aircraft completely ready to start up before taking it out of the hangar. Depending on the ambient air conditions, it is possible for frost to form on the wings in just a matter of minutes, so departing as quickly as possible is necessary. Wing covers are another effective and relatively inexpensive method of preventing wing contamination. Like other forms of de-icing, there are pros and cons. While inexpensive, they can be difficult to install or remove, particularly on a windy day. The pilot must be extra cautious not to damage the aircraft during this process. And remember, although the wings have been covered, other areas of the aircraft have been left exposed and may still require the use of another method of de-icing. Manual methods of snow and ice removal, although a lot of work, can be quite effective at removing the contamination from critical surfaces. Brooms and brushes are some of the most common devices used. However, be aware that significant damage can be done to the aircraft while utilizing a manual method of contamination removal. Take great care in using this method, particularly around pitot tubes, static ports, and the windscreen. Perhaps the most well-known method of de-icing is using a glycol-based spray. For general aviation aircraft, the Type 1 de-icing fluid is used most often. Type 1 fluid is orange in color and is a hot mixture of glycol and water. Because it is applied hot, it's effective at removing much of the contamination from an aircraft. It's also a good idea to complete your walk-around and engine run-up before being de-iced. There's no sense in paying to have an aircraft de-iced that's not airworthy. And your mechanic will thank you too. It's not nice to work on an aircraft covered in de-icing fluid. It's recommended that the pilot in command monitor the application of Type 1 fluid to ensure that it's not directly sprayed on engine openings, windows, pitot tubes, and static ports. And if the de-icing fluid does get onto those areas, it's the PIC's job to ensure that they're cleaned and that the aircraft is still airworthy. And if you aren't able to depart soon after your aircraft is de-iced, remember to check the critical surfaces once again before takeoff. Depending on the atmospheric conditions, frost or other contamination can form quickly and you may not be able to see it from the cockpit. Keep in mind that there's no such thing as just a little bit of ice. So allow lots of extra time to ensure the aircraft is clean and ready for a safe flight.